If we require control over two or more VIs running in parallel, or a VI and sub-VI, we must use a global variable. Global variables work the same way as local variables, except you can communicate to multiple VIs. Keep in mind that you need to have all VIs that use the global variable within the same LabVIEW project. I will now demonstrate an example using global variables. Using the example we set up for local variables, I split up both while loops into separate VIs and then save them into one LabVIEW project. Notice that within the second while loop, I have deleted the local variable. In order to create a global variable, right-click the block diagram to open the Functions palette, navigate to Structures, and select Global Variable. Now place the global variable on the block diagram within the second while loop. In order to open the global variable's front panel, double-click the icon. On the front panel of the global variable, place a stop Boolean control. Now I will save the global variable. I will name it new global. Now I will close the front panel of the global variable. Notice that my global variable has been added to my project. I can now select the stop Boolean control from my global variable. Right-click the global variable and select Change to Read. Now wire the output of the global variable to the input of the loop conditional terminal. Now drag and drop the new global variable onto the first while loop block diagram and wire up the output of the stop Boolean control to the input of the global variable. Now run both programs. Notice when the programs are run, both LEDs light up that the loops are being executed. When I press the stop button, both loops stop together. This example shows that two VIs run in parallel can communicate with each other through a global variable in order to stop simultaneously. Race conditions can occur when variables are used incorrectly. A race condition is an instance where the timing or order of execution of a program unintentionally affects an output or data value. This is the same condition that can occur within text-based programming. However, data flow programming prevents the occurrence of race conditions. In instances where data flow breaks down, such as in parallel programming, race conditions can still occur. In order to use variables in the correct manner, you need to perform the following operations in this order. Read the value of the variable. Then make a change to the value that you read. Then write that changed value back to the variable. Now consider what happens if two parallel loops happen to execute in the following order. Loop 1 reads the variable. Then loop 2 reads the variable. Then loop 1 makes a change to the value it read. Then loop 2 makes a change to the value it read. Then loop 1 writes its result back to the variable, followed by loop 2 writing its result back to the variable. When this occurs, both loops write a new value to the variable. This generates a race condition and can cause issues when one loop is expecting the value it wrote previously to the variable. The result from loop 1 is never read by the program because the result from loop 2 is written over it. When using variables within your program, it is always important to make sure that you account for race conditions or your program may not execute as you expect. In this tutorial, we covered the ideas that in LabVIEW the order of execution is controlled by the data flow through wires. However, when we have parallel loop structures, we cannot use wires to communicate data between two loops because data flow prevents parallel operation. Variables allow us to avoid this normal data flow by passing data from one place to another without connecting the two places with a wire. Local variables can only be used to pass data between two different locations in a single VI. Global variables can pass data between multiple VIs running in parallel or a VI and sub-VI, but need to be utilized in a LabVIEW project. When programming with variables, it is very important to keep track of the timing and order of execution. If used improperly, variables can result in race conditions, and the timing or order of execution of a program can inadvertently affect an output or data value.